In the vast, silent theater of the cosmos, where stars are born and die in cycles spanning eons, our solar system drifts, a familiar and well-charted island in a sea of unknowns. For millennia, humanity has looked to the heavens, mapping the predictable waltz of planets and the steady twinkle of distant suns. But the universe is not always predictable. It holds surprises, visitors from the cold, dark frontiers of space that remind us of the dynamic and ever-changing nature of our cosmic neighborhood. These celestial travelers, comets, are icy relics from the dawn of our solar system, their journeys often taking them on long, lonely paths far from the warmth of any star. Sometimes, however, their orbits bring them close, offering us a fleeting glimpse into the primordial past. And so it is that in the year 2025, our watchful eyes on the sky have detected something new, a previously unknown object emerging from the blinding glare of our own sun. Its name is C2025R2, SWAN. This is not just another speck of light. It is a messenger from the outer solar system, a comet making a rare and dramatic entrance onto the celestial stage. Unlike many comets, which are spotted on their long journey inward, this one played a game of cosmic hide-and-seek. It was detected only after its perihelion, the point in its orbit where it passed closest to the sun. Imagine flying past a roaring fire, unseen, only to become visible as you race away, singed and glowing. That is the story of C2025R2. Having survived its fiery encounter, it is now on a trajectory that will bring it into our view, on a path through the inner solar system. The discovery was made by the Solar Wind Anisotropies Instrument, or SWAN, aboard the Solar and Heliospheric Observatory, a joint mission by ESA and NASA that has been tirelessly monitoring the sun for decades. SWAN's purpose isn't to hunt for comets directly, but to map the solar wind and the hydrogen distribution in our solar system. Comets, being rich in water ice, release vast clouds of hydrogen as they are heated by the sun. It is this faint hydrogen signature, a ghostly halo invisible to most telescopes, that gave C2025R2 away. An amateur astronomer poring over the publicly available SWAN data first noticed the faint, anomalous glow. A new visitor had been unmasked. This method of discovery highlights a beautiful synergy in modern science, where professional instruments and the keen eyes of citizen scientists come together to piece together the cosmic puzzle. Let's be clear about what this object is and what it is not. The astronomical community has a cataloging system for a reason. You might recall another comet that generated excitement, 3I Borisov, or the tantalizing fragments of Comet Atlas. C2025R2 is a distinct entity. It is not 3I Atlas or any other previously known body. Its designation, C2025R2, tells us its story. The C indicates it is a non-periodic comet, meaning its orbit is so long that it has either never visited the inner solar system before, or its last visit was thousands, if not millions, of years ago. We are likely its first ever terrestrial audience. 2025 is the year of its discovery, and R2 signifies it was the second comet discovered in the 9th half-month of that year. The name in parentheses, SWAN, credits the instrument that made the discovery possible. Every part of its name is a data point, a breadcrumb on its trail through space. What does it look like? Early observations suggest a striking appearance. As the sun's radiation heats its icy nucleus, trapped gases and dust are released, forming a vast glowing atmosphere called a coma. For C2025R2, this coma shines with a distinct greenish hue. This color is a telltale chemical signature, primarily caused by the presence of diatomic carbon and cyanogen. When these molecules are energized by ultraviolet sunlight, they fluoresce, emitting light in the green part of the spectrum. It's a process similar to how a neon sign works, but on a scale of tens of thousands of kilometers. This ethereal green glow against the black velvet of space makes comets some of the most beautiful and mysterious objects we can observe. Now, let's talk about its journey. Having swung around the Sun, the comet is now traveling outbound, its speed carrying it away from the heart of our solar system and back towards the depths of space. But its path will bring it relatively close to our own planet. The orbital diagrams, calculated from preliminary observations, are being refined with every new data point. These plots show a graceful, sweeping hyperbola, a trajectory that will carry it across the orbital plane of Earth. Mark your calendars for October 20th. On this date, C2025 R2 will make its closest approach to Earth. Close in astronomical terms is, of course, a relative concept. There is no danger of collision. It will pass us at a safe distance, a silent ship in the night. But this proximity will provide an unparalleled opportunity for both professional and amateur astronomers to study it in detail. The scientific value of such a visit cannot be overstated. Comets are often called dirty snowballs or icy dirt balls, but a more accurate description might be time capsules. They are composed of the original material from which our solar system was formed over 4.5 billion years ago. Water ice, frozen gases like carbon dioxide and methane, dust, and complex organic molecules are all locked within their nuclei. By studying the light from C2025 R2 with spectrographs, scientists can analyze its chemical composition. This tells us about the conditions in the early solar nebula, the giant cloud of gas and dust from which the Sun and planets were born. Is the water in this comet similar to the water in Earth's oceans? Does it carry the complex, organic building blocks of life? Each comet provides a new piece of the puzzle, helping us understand not just the history of our solar system, but perhaps our own origins. For sky watchers on Earth, the coming weeks will be a time of anticipation. As the comet approaches, its brightness is expected to increase. Will it become a naked-eye object? Cometary brightness is notoriously difficult to predict. It depends on how much gas and dust the comet is actively releasing, a process that can be erratic. Some comets fizzle out, while others can unexpectedly flare up, becoming spectacular sights. Astronomers will be monitoring its light curve, a graph of its brightness over time, for any clues. Regardless of whether it becomes a brilliant beacon or remains a subtle smudge of light requiring binoculars or a small telescope, its passage is a reminder. It connects us to the grand, cosmic environment in which our planet exists. As we track its course, we are not just observing a celestial object. We are witnessing a story unfold. A story of a long, lonely journey from the cold, dark edge of the solar system, a brief and fiery dance around our Sun, and a fleeting visit to our part of the cosmos. It is a journey that began long before human history and will continue long after we are gone. For a few short months, our timeline and the timeline of this ancient traveler will intersect. We are privileged observers. The data we collect, the images we capture, and the sense of wonder we feel will become part of this comet's legacy. As C2025 R2 recedes, moving back toward the cold and dark, it will carry on its silent journey. A faint greenish specter disappearing into the infinite void. And we will be left here, on our blue marble, looking up, forever changed by the encounter, and waiting for the next visitor from the deep. Thank you for joining us on this journey into the cosmos. The universe is full of wonders, and new discoveries are being made every day. If you found this exploration fascinating, please consider liking this video and subscribing to our channel for more stories from the frontiers of science. Stay curious and keep looking up.